I was reading that Valorant,
I don't know.
Valorant.
Valorant.
Maybe it's like Valor
Ant.
is the Valorant. Having the characteristics of Valor, is that what they're going for?
I think
It
so.
feels like a made up word, right? Did they just invent that word?
They definitely invented that word. Oh my
Monday
god.
night. Yeah, what?
I
What's
just
up?
saw I just saw the cute dog behind you.
Oh, yeah, I don't have my own I don't have my own video feed up. So whatever goes on behind me, I'm clueless.
It's probably an
Um
awesome dog, as far as I can tell.
yeah, so like major change to the stream today. First of all, the start of our new Monday Thursday cycle. Tuesday, Friday, we barely knew you.
I feel
Second
like
thing,
we got to Friday and we were just like, wait, nobody's online.
Yeah.
We're not even sure we want to be online. So yeah,
right. Second thing is now the stream features a dog with the zoomies behind me. Well, which is kind of what the people want.
it's an A+ choice, frankly. Yeah, everyone wants that.
We've been looking to make improvements to the stream, and I think this was the boldest move we could have made.
Absolutely, animal companions are really in right now. So
Yeah.
checks out.
Sweet. I just got Ngrok, and the reason why I got Ngrok is that we might have multiplayer kind of working.
I'm excited to try this out.
Okay. So I think maybe the way that I would like to play today is perhaps make sure that it works,
Mhm.
and then try to walk you through what the changes were. And then after that point, I would actually maybe popcorn it over to you and see what you want to work on.
Sounds great.
Even though I think I'm the designated typist today, but I think I'd like to follow your curiosity once you figured out what the implementation is like.
Sounds good.
Cool. All right. So I've never tried this before, which is to run the game with a separate server process and two browser processes that are also running at the same time. But I think that's the best way to actually demonstrate that this works. So let's see if I can't get yet another window. Move this bad boy to the middle. Still clumsily learning my magnet hotkeys here. And what we are going to do is we're going to run our magical yarn dev.
I'm curious to see how the how the server ends up like this. So it's no longer in the browser.
Yeah.
Great.
The hot reload time takes a little while. I think part of it is that it's compiling TypeScript multiple times in different ways. So the server's now live. I don't know if that's visible down there. It's really, really tiny. And we're going to go to localhost 3000, local hot, as it is today. This is actually kind of interesting how there is a little strip of color in there. We haven't quite figured out that bug.
I wonder about that one.
Yeah. So you can see the player numbers aren't assigned yet, right? There's kind of like a bootstrapping phase that we'll talk about. And now we've got two things running.
Whoa.
The FPS is actually not too bad right now. And I believe, I should be able to drive around. The frame rate's just crushingly slow, right? But you should be able to see the other one running. And for some reason, it's way faster than the other window. And I think what we're seeing here is just the Mac OS scheduler. Yeah. And then if I click over to the other window and I can drive the other tank, you should be able to see I'm controlling the window on the right.
This is amazing.
Yeah.
Holy shit.
It's amazing, and yet we wrote the code, right? Like all the bones were here. And then what happened over the last 3 days is I just kind of tried to piece it together. And for some reason, the particle emitter works, which is not what I would have expected. I actually haven't quite figured that out yet.
Wait,
but it works.
Why wouldn't it work? On both sides, you mean?
You're right. It would totally work.
Yeah.
It would totally work. It's just simulating the particle emitter as if it happened several frames after the bullet was actually fired. So it'll seem laggy. So I'm controlling the left window, the left tank. And so I think the particle emitter seems a little laggier. Like physically, the particles are actually kind of like appearing.
Interesting.
later than they should.
Now that's interesting because I would expect the right side to be as correct as possible because it should only receive inputs for the tank controlled from the other window, like the instant they happen. Like it never has to catch up to that, right? Because we're not really predicting other player input yet.
Yeah, but by the time that like the other client, which is player 2 here, the right window, by the time it simulates the input coming in from the other client, it's already ahead of it, right? And so it's playing it back, right, doing the prediction. But because the particle emitter isn't part of that simulation, it's just a side effect. That means it's getting played back numerous frames after it should have been played, right? Because there's no time travel.
Right. Okay.
Yeah, and so that means the bullet will have traveled further along. The bullet is getting simulated perfectly. Now, if we made every single particle part of the simulation rather than it being a side effect, then the particles would be perfect.
That makes sense. Right, I forgot that the bullet is shot 20 frames in the past, and you play it 20 frames in the future and sort of are predicting it into the... Yeah, that makes a lot of sense.
So
okay.
What I would love to do is set up ngrok and see if this will work with both of us playing.
I'm ready.
Right? And I'm not ready. We'll see what happens here. Okay, so the server actually crashes once there's a WebSocket that's not available anymore. Details.
That's
trivial
fine.
details.
Yeah, I mean... What else would it do? What other purpose could it have?
Like, exactly. Like, there's no other player. What's the point of even continuing to exist? Right? Okay, so we're going to fire up the dev server again. And then I'm also going to connect the dev server to the friggin' internet. And as long as we don't have any trolls watching on the stream, you can connect to this. I don't know. Should I Slack this to you?
You can Slack it to me, yeah. I was going to type it out from there, but that's even easier.
Okay, I'll Slack it to you. We're going over to Slack. Going down to Slack.
Oh, this is great. Oh my god. The first failed to complete tunnel connection. Is your localhost 3000 started yet?
It should be.
Sure looks like it, yeah. All right, let me try again.
Although, for some reason, it looks like it crashed. Is it possible that we can't do a WebSocket through ngrok?
Ah.
That doesn't seem right to me.
That's pretty... Let's see. ngrok's tunneling works without any changes for WebSockets, but...
Let me try firing up the server one more time.
Okay.
And let's actually just let's get a dev server in here. And I believe it is npx ts node out server.js is the name of the bundle. Right, because Parcel is building for the server side now. And we'll talk a little bit about that. So yarn dev server. ngrok is chill there.
Can you switch over to the server before I connect? So I'm gonna hit the button.
Okay.
Oh, okay. I'm online.
Okay. And now I'm player 2. Let's drive around.
Oh my god, what?
So my player is a little bit constrained, but you're driving around. You're chill. You're doing great.
Now, why are you a little bit constrained? Yeah.
It looks like my lag is way behind. So my server is just way behind the other client. And I think it's because we connected. No, if we should have connected. Oh, did we connect? So this is actually something we could talk about. So if you connect much earlier than me, I bet that's what it is. You connect much earlier than me, and so you're simulating ahead of me. The server tries to give a little bit of buffer to let other clients that are lagging behind
Interesting.
participate, but if they're too far behind, they'll just like forever not be able to catch up. Right.
Mm-hmm.
So everything that you see right now is my prediction, right? Is
Right.
prediction, and then the server says, nope, actually didn't happen, right?
Mm-hmm.
Because you're too far behind.
Yep. On my side, you're doing nothing.
Okay, that's exactly what it should look like. But you're driving around, right? Like, so if you drive around right now,
Mine's great. Yeah.
Yeah,
And I can see myself reflected on yours, which is
yeah,
amazing.
this is great, and you look really smooth on this side, which is really cool.
It's really smooth on this side. What is the so? Can you explain our new numbers? I see FAOS and frames ahead of server, I assume, and SIPF.
I'm going to go ahead and terminate the server.
Oh yeah, let's kill it. Let's kill it.
This costs a lot of CPU on my end here.
Fair.
Yeah. And then I don't know what, I'll just open a new tab, and then I'm going to close this tab. Yeah, so let's actually talk through the architecture now, and maybe we can figure out a way of making this a little bit more playable, right? And maybe we can start with that and then go from there.
Mm-hmm.
Okay, so let's really rewind it back. Well, actually, you were asking about numbers, right?
Yeah.
So let's just do this again, and let's both try to hit localhost 3000 on the count of 3 through Zoom.
Okay.
1, 2, 3.
Too many connections. The tunnel has violated the rate limit policy of 20 connections per minute by initiating 41 connections in the last 60 seconds.
41 connections?
What the fuck?
Oh, you know what it is? It's because the client pulls. It pulls the yeah. So that's interesting. We could turn polling off. How long does the rate limit last on Ngrok, I wonder? Did it tell you what?
20 connections per minute. So it's looking at the last 60-second window.
Okay.
Yeah.
Why don't we?
Yeah, let's turn that down.
Turn the polling off. Yeah. Let's just not have hot reloading, right? Let's just not do that.
Well, that's easy. Yeah, I love it.
And then we have to wait for the. Just gonna complain that I'm not using something. There's a bad import. We'll see.
TypeScript.
So
pushy. Man, okay, this is really cool.
It's pretty great, right?
I feel like you got all the pieces to just fall into place in the right way. I'm so happy and impressed.
Okay, server built. The whole build key thing that we talked about last time had to get a little bit more complicated because we're actually making a bundle, but
okay,
still not too bad. The hot reloading is not interesting. We won't talk about it. We can if we want, but it's not that interesting, I think.
No, I think if that's working, that's like the part I'm least concerned with. Because yeah.
Wow, this is taking forever. I think it's because I'm running the game at the same time. Yeah.
Yeah. Oh, and immediately it starts going.
So this is kind of mysterious. This is sort of mysterious activity from the macOS scheduler. Should just be running now. Come on there.
It started.
Okay.
Yeah.
So on the count of Zoom 1, 2, 3. So it's 1, 2, 3.
Okay.
All right. I'm able to drive around. Oh, you're able to drive? This is fantastic. Oh, I just fell behind again. That's weird. So I guess basically at some point, because I'm running the server and the client at the same time, I just need to increase the buffer. That's all that needs to happen, basically. Okay, so this makes a lot more sense, right?
Gotcha.
Basically, yeah, go ahead.
Oh, it seems like I'm just surprised by this behavior because I feel like you should have the lower transit time to the server at all times, right?
It is, but the CPU simulation is so slow, right? The client side, the in-browser simulation on my side is so slow because it's having to jump back and forth between the server and the client at the same time that I'm falling more than 10 frames behind you, if that makes sense.
Gosh, yeah.
So, okay, the two numbers that you're seeing up there, FAOS, is frames ahead of server. And what I'm doing there, and I'll have to check the math again. Let's actually, rather than me talking about it, why don't we just take a look at it, right?
Let's do it.
So if you take a look at the client. So basically, when we receive, when we go through server messages that we've received over the WebSocket, and then we figure out like what the committed frame currently is. And I believe we process all committed frames that are less than or equal to the current client frame. Is that right? Is that what we do here?
All committed frames less than... Yes, correct.
So we basically say, yeah, for each server frame, we're going to loop over and simulate. But we made sure that we filtered out... Yeah, we basically process everything. Wait a minute. This is interesting. Is there anything here on the client side that ensures that the server frame is less than or equal to frame? Frame is what the client is running at. Like, is it possible that the committed frame is greater than the local frame?
Oh.
I think it technically is right now, right?
Currently, but that should be hard, but yes.
Yes, that's why we're seeing negative, right? So if we go back to the client, basically what I'm saying is I'm taking the current frame and I'm subtracting the committed frame. This is the last server frame that we're actually able to update and commit to local state. And we're sampling it in my running average class. And then we're just rendering that, right? So that's frames ahead of server. So this should always be positive. And if it's not, you are way too slow, right? Your client is running way too slowly.
Gotcha.
SIPF, I don't even remember what this stands for. So let's actually let's just search for it. It is server inputs per frame. Okay, so this is basically just a way for us to measure how many messages per frame we're receiving from the server. So as you drive around, we're actually receiving client messages coming in from the server, and this is just telling us how much we're getting per frame.
Gotcha.
And so rather than console logging that in the client, because it slows down the browser so much, I just wanted to like get a running average to show that.
That's great.
So basically, this is just how much activity we're getting from the rest of the game, whether it's coming from the server or coming from other clients. This is just saying, okay, over the wire, we're just receiving. So if you continue to drive around right now, you'll see that number pop up to like, yeah, we're getting. Should really just be like 2 or 3.
It's interesting that I feel like it gets closer to 0 or 1, and then the less input I give it, the higher the number goes.
Yeah, it goes up to infinity, right?
So I noticed that server inputs per frame. Oh, I guess we're averaging, and then we're just running out of our running average.
Well, where are we sampling, right? Yeah. We're sampling at the very top of the update. So I don't know why it's going to infinity. Maybe because we should just be if.
Now, are we not sending a server frame to either client if there's no input from either player?
Sorry, can you say that one more time?
Yeah, if neither player is like pressing a button, and there's nothing on the screen triggering any sort of client message, the server is actually not sending anything for the current frame. Is that correct?
Yeah, it should count as 0 basically.
Okay. I wonder if we need like a heartbeat or something.
Oh, I'm doing 1 over. Is the 1 over wrong? Yeah, that's wrong. All right.
And we don't have hot reload, so neither of us will see it, but we could refresh.
We could.
Or you could do that.
I'll just do this, and then we could just both reload on the count of 3 again. Let's let it compile again.
Oh, yeah.
I think the expensive CPU stuff that's going on my computer right now is we're compiling stuff, we're running the game in the browser. We also have Zoom going on, and I'm just sending you 1080p, right?
Yep.
Yeah.
Yeah, 1080p.
So that's enough on this computer for it to be slow.
Plus your face, yeah. Yeah, it's like
plus my My ugly mug, yeah.
Two video streams, really chowing down on the processor. I wonder if this is a solid case for us to go back to the video capture through the PC.
It's and then do zoom on the PC.
Mm-hmm.
I see. Yeah, that is a possibility.
If you open up Activity
I could
Monitor,
also buy another computer.
Well, yeah. I was gonna say, if you open Activity Monitor, I'd be surprised if Zoom is eating too much CPU.
Yeah, let's check it out. Fun to think about.
Mm-hmm. For what it's worth,
Zoom is actually dominating it right now.
All right.
Oh no, wait! Now Firefox. Well, what is Windows Server?
That's just like Mac OS.
Okay, thanks Mac OS.
Yeah, Zoom's up there, and I'm not sure how many cores you got, but yeah.
Okay, let's go ahead and reload on the count of 3.
All right.
1, 2, 3. I don't think it actually matters. I don't think the timing matters that much. But okay, I can drive around now, and at some point I'm gonna. Yep, I hit it. Yeah.
And you just go negative. Ah, interesting.
Yeah. Okay. So the inputs per frame now makes a little bit more sense. We're getting about 2. 2 should be the limit, right? Because essentially we're getting the two inputs that you're sending, which is tank moving and shooting.
Mm-hmm.
Yeah.
Oh, I see. Right. That's the total maximum average. Yeah.
So server inputs per frame is just basically like the amount of a measure of the activity that we're receiving from the network.
Mm-hmm.
Right.
Totally.
Super cool. All right.
Nice.
Why don't I go ahead and stop the server right now? Just because for some reason I get nervous when I hear my computer fan going, and it's definitely going right now. And I can walk you through how this what's going on here.
That sounds great. Also, I want to toss it out there. This kind of just like hangs out in your 60 FPS render and update on Windows as well.
On Windows. Okay.
I'm tempted to dev on Windows now with this beefy CPU.
You know, we could do Windows.
Mm-hmm.
We could do Windows. I'm not sure if we'd be doing this in Windows proper or if we'd be working in WSL. Last time I tried using WSL, it doesn't really work. It doesn't really play that nicely with native Windows applications. And if your Windows application needs to like write to the Linux file system, it chones everything as root.
Ugh.
So I was using this. My Git client is called Fork. I really like it. It's like a GUI Git client, and I was using that to connect to the Linux file system to just do like Git GUI stuff. And then I looked in the file system, like, why the hell is everything owned by root now?
Oh no.
And it's just because if anything reaches into the Linux file system from the parent operating system, it's just going to do it as root. And not only does it do that, it chones it for some reason. So,
that's annoying.
Yeah. Okay. So, is it better to start with the server or the client? Maybe it makes more sense to start with the server.
Let's start with the server.
Okay. So first of all, we have a new file called server main.
Nice.
It lives at the top because all parcel entry points need to live at the top level. So
Interesting.
Let me see that there. I tried putting it into a folder called entry points because that actually feels like a logical place to put it. And
absolutely.
I couldn't find anything. So, yeah, go figure, right?
Gotta wait for parcel 2. That's okay.
Yeah. Or maybe I just screwed something up. That's also totally entirely possible. Okay, so this file is actually similar to the serve.js that we worked on Friday. Basically, it runs a bunch of things. It runs an API server through Koa. It's an HTTP web server.
Nice.
Right? It runs a WebSocket server. Right.
I noticed there's no Koa simple WebSockets in here. Great choice.
Yes. I actually just totally pulled that out. We'll go over the code there in a second. And then it also runs the game server here. This code should be kind of familiar to you.
Oh, interesting.
It's
okay.
no longer in main.tsx. We just pulled it out. And then I just sort of re-imported it. I aliased the import as game server because there's too many servers going on in this file. There's literally 3, right? So I just wanted to be really clear that one was the game server, one was the HTTP server, and one was the WebSocket server. Right?
Cool.
I'm not sure why WebSocket server needs to be a server in the first place. All you're really doing is just hijacking the TCP socket that the initial HTTP request is on. I don't know why it needs to be a server. But I think that's just the architecture of that particular library. Okay. So the game is running in the background. And now when you instantiate the server, you actually feed it a couple of properties. You feed it the number of players that you're expecting.
Nice.
And then the number of frames behind the client that the server has to respect before it starts simulating. And so if we don't have this, and either of our clients are slower than the server will simulate ahead of the clients. And the server's rules, it'll ignore any client inputs that are for frames less than its current frame, right? Which is why we need to have this buffer here. So the server always needs to simulate behind the clients, right? And in previous streams, we were experimenting with setting that value to 10 or 20 or 50 or 100, right? That's pretty much what this number is.
Cool.
Right. Okay, and then it just goes on its merry way and starts simulating. Let's talk about the WebSocket really quickly. So the WebSocket connection is here. And it's pretty simple, actually. Basically, what you do is you look for the header. There's a header called upgrade, : and if the value is WebSocket, that's what you're looking for. Otherwise, if it's not, then you really have no business calling this particular endpoint, and we'll just give you a 400. You also tell Koa not to actually send back an HTTP response.
Cool.
Which I think Koa basically treats as, okay, something else is going to take over the TCP socket at this point, right? Then you do this. You call handle upgrade, okay? And this is like the WebSocket server thing that we instantiated before anything happened. You pass it the request because it needs to pull some variables out of the HTTP request. This is just like a node HTTP library request. You pass it the socket because this is what's going to take over. I don't know what the buffer's for, but that's just what was in there. And then you call it. You give it a callback to say, basically, we'll call this callback when the WebSocket has been established. So there's actually a lot going on by the time this WebSocket gets this callback gets called. It's like the whole initialization WebSocket protocol handshake stuff. So basically, by the time that this callback gets called, you know that the socket is open. You're able to send and receive over it, right? What I did there is I bundled that into a promise. This is just all JavaScript magic, so that I could wait it so that these next lines would happen after the callback gets called. Right?
Cool. Yeah.
Yeah. So that's it. At that point, I just log out to the CLI that we have a new connection, and then we tell the game, hey, you've got a new client. And there's an abstraction that I use for sending and receiving messages between the game and the client. There's actually two different ones. There is an iClient connection, which confusingly is held by the server. This is the server's connections to multiple clients. And the interface is really simple. Either I can send server messages to that client, or I can consume whatever messages have accumulated over time from that connection. Right? And then there's actually a corresponding one that looks almost exactly the same called the server connection. And again, confusingly, the server connection is held by clients when they talk to the server, and it's the same exact interface. Hey, I can send client messages that come from me back to the server, and then I can just consume server messages that I've received. If we look at the actual implementation of these two classes, they're actually completely identical. What you do is, I made it an interface because I'm pretty sure we're going to want to fake this at some point, right? We're going to want to fake it either because we're running locally or in the same process or in a test or something like that, right?
Absolutely.
Yeah. So there's one concrete implementation of the interface, which is for WebSockets. What you do is you pass it the WebSocket that's already been connected, and then you say, hey, I'm going to listen to messages coming from this WebSocket. And when I receive them, I'm just going to parse them as JSON and then tell TypeScript, hey, I just trust that this is the right structure. We're not doing any validation or anything like that. I put it to do here saying that this is potentially kind of a foot gun, right? And then we just take that message and we just push it on the end of a local array, right? And then whoever holds this connection wants to read those messages, they call consume, and all it does is just literally pass that back and then set it to nothing. I use this interface as opposed to trying to like implement the JavaScript iterator or iterable protocol because I figured we never actually want to loop over everything. I think the only consumption pattern that we have is at the top of either the client or server update loop, we call consume and say what are all the things that we've gotten since the last time I did this, and I want you to forget about them. Just tell me what they are. I'm going to do whatever I will with them, and then the connection doesn't need to worry about them anymore.
Yep.
So that's why I kind of wrote the API that way, right? And then on the sending side, what we do is we just take a client message or server message, depending on what type of connection this is, and then we just stringify it and send it back over the WebSocket, right?
Cool.
So yeah, that's relatively simple. So when you connect a client, right, the game server has this thing. What it does is it says, okay, well, I'm actually going to store that connection in a list of connections. The game actually, or the server rather, used to have an array of client objects, right? That was when the client and the server were in the same process, so we could actually just like share pointers to clients. But here we need to share connections to clients, right? And all it does is just say, I'm going to just throw it in at the end of a list, right?
Great.
However, if we already have too many connected, then we've already reached the maximum player count, and we just do nothing with the connection. We should probably tear the connection down, but I don't really care, right?
No, whatever.
Yeah. So what this means is that if you were to reload your browser window, you would not be allowed in because your old browser request is still occupying that connection, right? And the WebSocket would get torn down. So like probably we need at least one more layer of indirection here for this to like be really satisfying, which is to say that like there's a cookie or something in your browser and we associate the connection to a particular like session key or something like that. Some layer of indirection that we have in there, right? And that would allow someone to reconnect to the server if they wanted to and resume their session basically.
Yep. Interesting.
Okay. So we look at, I think it's game.ts. There's an enum here of games. Yeah, sorry, go ahead.
I was going to say, this is all looking, blessedly familiar. This is a lot of the architecture we've already set up. So it's great to see it distributed across a couple files and actually like talking over true messages instead of like just pushing into an array. This is great.
It's validating that the stuff that we were doing for the last 6 weeks actually has an analog to this actually running over a network, right?
Yeah, exactly.
So it's cool. Our kind of gamble of like just trying to write it out locally with a pretend network actually wasn't too bad. Right?
Yep.
However, the stuff that we're talking about this instant is new, right? How do we actually? This is all. We're just talking about the details of how it actually has to like establish connections. We actually have to do a protocol that precedes any of the actual back and forth communication, right? So in game state, I'm not sure if this is a true game state or not, because to me, game state is about the simulation and progress of the game, and connecting is more of, I almost think of it as like a higher level state. It's either you're connecting or simulating the game, and within this game simulation, probably running you died level complete or like kind of children of that mode, but whatever. I just threw this into one giant list. So there's a connecting state. And game state is actually shared between both the server and client. And both of them enter a connecting state, although probably, honestly, another reason why this shouldn't be in the enum is that I think we should treat the client connecting state and the server connecting state as two philosophically distinct concepts, right? But they both enter this state initially, right? We used to have a state called none, right? That was just like the initial state. Now their initial state is connecting.
Okay.
Both the client and server. So what does the server do in connecting state, right? Well, let's just take a look at the update. So first of all, when we are connecting, basically what we say is like if the number of connections is equal to the player count that we expect, and this was essentially configured during the constructor, like we pass this value into the constructor, then we're going to actually just go to make a state transition into the running state. And so that's why your player number is -1 until we get two client connections, and then we can actually start the game right then and there, right? There's a bunch of stuff above this. Maybe we can talk about this a little bit later. Okay, so when we are running, Okay, let me talk really quickly about the state transition, right? Because set state to running actually does some fun stuff. And that happens here. This all used to be in a function called start play. It felt weird putting that as a function in the class. It was kind of a private function. Maybe I should have just made it private. But like I thought it was short enough that I could just inline it here, and it's clear and easy to read. We do a lot of the same stuff as before. This is what was in the start play function for the server. But then what we do is we also tell all the clients, hey, we're going to start the game now, right? And so we send a new server message called start game. And so we actually have more than one type of server message now. I think in the past we actually had just the frame update, right, which is just all of the client inputs from every single client that the server has said, this is what happened in this frame. I don't care what you think happened, this is what happened, right? So we have a new message from the server that just says, hey, you can start the game. And by the way, here's your player assignment. Here's the number that you get.
Nice. Right?
Okay. So this is why all of our synchronizing and the reloads, 10 or 20 minutes ago was pointless. This actually all happens at the same time. So so we didn't really need to do that, was cool. I think the gist of it. Yeah. Okay, so the clients are going to do something fun when they receive a start game message, right? Let's actually talk about the story right now, right? Okay, so let's go back to main.tsx. That is what's running in the browser right now. Lots similar here. We have killed the other client simulation. We have killed the server simulation. We're no longer running all three of those things in the same process. It's just the client, right? And so we're running a render loop, we're running a simulation loop. That's going on there. And then after those have kicked off, we create a connection to the server. So this is connecting to whatever URL you've typed in here, /API/connect, and we saw that in the server entry point, right? That was right here. Yeah, so the client, once it receives that connection object, and this is really kind of simple, right? Creating the server connection object just basically says, give me a new WebSocket. The WebSocket library is part of the browser API. It's just there. All the browsers have it. Gives me a new WebSocket. And then once that socket is opened, we are going to create a new server connection. That's the class that we actually talked about before, right? Just like the send and consume.
Now, I noticed in main TSX, the frame counter is still going up in the client simulation loop.
Oh, that's a great question.
Yeah, because how does that get synchronized with the server?
I think that this probably needs to change, right? And this is probably a bug.
Okay. Because this would require like a tighter coordination on our side to get it to work correctly.
I think that we shouldn't be passing the frame in anymore. I think client update should just be tracking the number of simulations that it says. This should just be an internal number, I think, from here on out.
That seems reasonable because we want to set it to 0 when we get the server connection message.
Exactly. Yeah. Exactly. Yeah. Either that or the server will just treat itself as being really far behind.
Yeah, but the two clients will have started, like, if I was waiting for a while, I'd be like a couple of thousand frames ahead of you.
Exactly.
Yeah, so.
Exactly.
Okay, cool.
That's a good thing to point out. It didn't even occur to me when I was writing this.
I wonder if there's something where whichever client sort of wins is what sets the server pace, and then is what sets, like, one client falling way behind.
Yeah, that's possible. It's also the case that like my client simulation here is probably running at a slower FPS than yours, which is disastrous, right? I think our assumption is that you would basically do minimum 60. We could try turning the FPS down for the update, down to 30, and see if it's.
Yeah, right. Because if I'm faster, then I actually am getting more ticks ahead of you on a server that is processing, and you're just falling behind. Yeah.
Exactly. Yeah.
Okay.
Okay. Yeah, because I'm not in a death spiral per se over here. I'm just like never going to catch up to you, right? If my FPS is slower, right?
Yeah, bummer.
And that seems like a problem. We should probably also just increase the buffer time as well. Okay, so when you connect the client, it actually just sets the server connection there. So the update is just cooking, right? This is the client update. It's just cooking the entire time. And when you are in the connecting state, all it's really doing is just saying, okay, hey, what are the messages that we've gotten from the server? And so let me actually talk a little bit about where these are coming from. So at the very top of the update, what we do here is we say, okay, the server messages we'll just initialize as this empty array. But if there is a connection, we're just going to consume all the messages that we've received. And then call it the server messages that we're going to handle for this frame. Right? And then if the server messages are... And this is interesting because notice that this is temporary. We don't store this anywhere. We're not pushing it at the end to the end of a container or a list or anything like that, which means that like any server messages that we've received, we assume that the client update will just handle this frame, right? We'll just assume that the client update will handle all of them, which means that the server updates cannot be about future frames, right? Or else you're not going to be able to see them correctly, right? Yeah. Okay. So if you get the start game message, we pull the player number off of that, and then we say, okay, we're going to start running the game, right? And then we call start play. I didn't factor it out on the client side. This should look pretty familiar. The only thing that's different is that we also set up some rendering stuff, right? And then we're in the game, right? And then kind of everything else sort of falls from that. You know, anytime something happens input-wise, we had already wired this up to send message to the server, right? I don't know if you remember this function here, send client message. Yep. What it does is it tells other systems that are running locally about that client message, but then it also tells the server about it, right?
Nice. Okay, yeah, that looks very familiar.
Yeah. And we had this all wired up before, right? And so that's why your shooting and that kind of thing is making it over the server, right? Similarly, at the end of when we're running the game on the server side, we're in the server right now. Basically, at the end of this, we just say, hey, all of the server's doing much more complicated state maintenance than the clients are, because it has to remember not just the inputs that are happening for one client. It has to remember inputs from all the clients. Not only that, but it has to remember, because the server's running behind the clients, it has to remember inputs for future frames that the server hasn't simulated yet, right? Because the clients theoretically are running ahead of the server, right? So at the very end of the frame that the server simulates, the server's basically saying, okay, I've simulated up to this frame with a set of authoritative events, and I'm going to send those authoritative events out to my clients. And that's what's just happening here. So we're iterating over all the client connections and just saying, hey, you get these, this is what happened this frame. Deal with it, right?
Nice, yeah.
Okay. Let me pause right there. Any questions before I move on?
No, this is great. I mean, our architecture is extremely similar, so
yeah,
same paradigm.
Exactly. Yeah. So I think the new thing that we had to worry about, because we're actually on a network, is the fact that the client is running ahead of the server, and we just actually have to remember those inputs. Okay. So at the very top of the server update, this is actually really similar to what happens at the top of the client update, right? The top of the client update says, and let me scroll. Get me scrolling for a while. The client has a lot of like rendering stuff that the server doesn't have to deal with. Very top of the client update, you pull messages off the connection, and you can just forget about them after you're done with this frame. We're not storing them anywhere. We're just getting rid of them. The server can't do that. Right? So the server has to do something that's a bit more complicated. So what the server does is it says, okay, first of all, I have multiple connections, so I'm going to iterate over those. And there's probably multiple messages that I've received from each connection. If that message's frame is behind my current frame, that client was too slow. I'm just going to forget about it, because I've already simulated past that. I can't do anything with that, right? And so this is the exact reason why I can't drive around. Well, Wait, can you drive around right now? Who else is playing right now? Are you playing?
Is the server's not
the
even
server's
running.
not running. Okay, so I'm simulating way ahead of the server right now, right?
Right. Right. You've passed the last frame that you know about.
This is the land of pure prediction, right? Because we're no longer receiving any updates from the server at all.
Yep.
Right? That phrase is turning out to be a little bit useful, right? So what was happening before is, I was seeing myself sort of shooting and then not being able to move at all. Because what was happening is I was predicting ahead of the server just a tiny bit, and the server was then shooting me down, saying like, hey, I didn't actually receive any of that. None of that actually happened, right? And that's because of this line of code here.
Yep.
Then we want to actually store this stuff, right? And message.frame, what this is saying is message.frame is greater than simulation frame if we get down to the line 84.
Mm-hmm.
But we don't know how much greater it is, and it could be arbitrarily far ahead, right? Clients could, like, right now, this client is now probably millions of frames ahead of the server because the server died, right?
Exactly.
And I think the promise that the server is making right now is like, I don't care how far ahead you are of me, I'm going to remember what you pressed, right? Or I'm going to remember your inputs.
Mm-hmm.
So what we do is we create this index, and what this is actually, it's a little complicated, but like what the client, there's this client messages by frame. We had something kind of similar before, but now this became an array of arrays.
Mm-hmm.
And the first array is the groupings, right? Okay, let me actually talk about the inner array. It's just like all of the client messages that we've received for a particular frame. And then we have multiple frames worth of that, which is the second array, right? And then the index that we've calculated here is just like how far ahead, like it's basically like what frame should this message get stored in relative to the current server frame, right? So it's not the absolute frame number, but it's relative to the simulation, like the server's current frame.
Interesting. Right? Okay.
This thing here is just to ensure that we actually have an inner array to actually push stuff onto. So basically I'm saying, okay, I'm going to take the current length of that outer array and then iterate up to the index that we calculated here and just like push another array on there if it's not there. That just makes sure that we have something at the very end of this array.
Totally.
Because what we're going to actually do is shift off of this outer array. Like basically what we're saying is once we're done simulating this frame, we're just going to erase those client messages out of our history because we don't care about them anymore.
Mm-hmm.
We could push them onto a log if we wanted to do debugging or whatever, but like right now we're just getting rid of them. So we shift the array forward, right? It's a queue basically. So there is a new type of message that the client sends to the server, and this is what you and I were talking about earlier today. Because before I was having this problem where I was running 2 clients on my computer and the server on my computer, and I was trying to do like a full screen capture at 4K. And basically what was happening is that the browsers were running much more slowly than the server was. Go figure. So the node simulation runs faster than the in-browser ones. Right?
Mm-hmm.
Makes sense for probably a lot of different reasons, right? What that meant was that basically the 2 clients would fall really, really far behind, and neither of them would be able to move at all. So what I wanted to actually do is figure out a way to say, well, the server shouldn't just try to outpace the clients. Otherwise, it's just like, what's the point of that, right? All of the clients are going to run afoul of this rule right here, and nobody's going to ever be able to send anything. So basically, what I was saying is that the server should basically never run faster than the fastest client plus some grace period, right?
Mm-hmm.
Which I think is more or less the rule that we're looking for, right? We don't want to compensate too much for the slowest possible client, right?
Right, because they would actually bring down the whole game.
Exactly, they'd bring down the whole game for everybody, right? Because the longer that basically the longer that the further behind the server is, the more into like the higher the probability of misprediction becomes on any client. Right?
Yep.
And so this is basically like a misprediction limiting factor. So what I did is I basically said, okay, every client at the end of its frame is going to send this message called frame end. This is a heartbeat.
Mm-hmm.
I didn't call it a heartbeat because a heartbeat is a little bit ambiguous about where it goes, and frame end makes a little bit more sense, or is a little bit more explicit. So if you look at the end here of the client update, it says, if we have a server connection, I'm at the end of my update, so I'm just going to send, I'm going to tell the server, hey, I finished the frame, and this is the frame number, right? Now, what that does is it guarantees the server knows at all times where the clients are. And if we didn't have this event, the server would only know where the clients were if there were actually input events that the client was sending to the server.
Correct. Yeah.
So this basically just guarantees that there's something. It's essentially a no-op that tells the server what frame you're on.
Mm-hmm.
Okay. Because we have those, what we can do is we can basically just set a high watermark inside the server. This is server state, saying how far along is the fastest client that we've got, right? And we're just going to basically say, well, it's just the maximum between what I've already persisted and this current frame that I'm receiving, this current message that I'm receiving, right? And because this is a special client message, we don't really care about like broadcasting this out to other clients. We might care, actually. So we may end up deciding to get rid of this else here. But I basically just said, like, you know what? Like, I don't care about these to send. Like, we're not going to process these anymore. This line of code here is, or this paragraph of code here is really the only reason why we're sending this message. So we don't care about it anymore. So we're not going to actually put it into our history.
Cool.
Right. Otherwise we'll just put the client message into the history. Right. Okay,
yeah,
great.
That's a nice filter because we don't. Yeah. There's probably going to be a lot more state we actually don't want to coordinate across clients, but the client server do need to talk about. So
yeah, exactly. So okay, we've got this thing here, and when the game is actually running, we're going to actually look at some messages here, right? And so this is the shift I was talking about here. So we basically just say, okay, well, I've got my history here. I'm going to shift off the front of it, but it might actually be empty right now. So I'm just going to like default to an empty array. And then we're just going to go ahead and process those. We're going to simulate with those frame messages. This is all like relatively familiar, right?
Totally.
What's a little bit fancy here is this idle logic here. Okay, and the idle logic is basically saying that even if the server is running faster, and the server is probably always going to run faster than the clients. Like server hardware is like really beefy and powerful. Even if you're running on the same computer, your server is running in a Node.js process, which probably has less going on in it than Firefox or Chrome or whatever. Because Chrome has so much going on in it, it just means that even though you're running equivalent code, roughly speaking, whatever's running inside the browser is going to be a little bit slower, right? So the idle code here just makes sure that the server doesn't try to outpace the clients, right? So what we say here is if the max received client frame that we've got minus the simulation frame, so this is basically how far ahead is the fastest client from us. If it's less than some minimum number that's fixed, and this is a configuration variable, we pass this into the constructor, right? When we did server main,
right, so that's our original grace period of 10.
Yes, this is the min frames behind client, right? If the fastest client is not even 10 frames faster, then I just want you to do nothing, right? So what we're going to do is we're going to break. We're going to jump out of this switch statement. It's really weird to me to break early in a switch statement, but switch statements let you do this. I kind of like it, actually. I like being able to just say, okay, go to the top of this current function. It's basically what you do with like goto in some languages, right? What languages have goto? I think Go has a goto, right?
Yeah, a lot of them still do. They're just frowned upon.
Yeah, but you've probably run in the situation where you have like a double loop. You have a loop and an inner loop, but you want to like advance to the next thing in the outer loop from the inner loop, and like goto is useful for those types of things, right? Or you have some error handling code at the very end of your function, and you have multiple deeply nested code sites that you want to just jump out to that error handling code. Like that's what goto is kind of useful for, right? And essentially that's what's happening here. Is basically like if the server is basically getting ready to simulate past the buffer that we're providing for the clients, just quit. And this idle counter stuff is just a way for me to throttle some logging, some output here. I don't know if you can even see this. It looks like you were simulating ahead of the server all the time, so you don't see this stuff. But basically, I wanted to print out the fact that the server was entering idling mode. Like, it was still running, but it's basically saying, I'm not going to actually simulate anything right now because I'm running too fast, and like I need to let the clients catch up to me.
Gotcha.
Not only catch up to me, but run ahead of me by a certain amount. Like, I always need to be behind them by a certain amount, right? So that's what that is. So I think I've connected all the dots, actually. I think that's actually how all the pieces fall together right now.
Yeah.
Obviously, it's like really rigid. The way that you configure the number of players in the game is you hard code it, you know, and the way that you configure this buffer size is you just hard code it as well. But
yeah, but we can. That's a great place to start.
Yeah. So I know I wanted to throw it over to you, but the one experiment I would propose is the first thing that we did is we lower the FPS down to 30 for the update cycle.
I would like to see that.
And we increase the buffer size by, I don't know, let's change it to 20.
20?
Right? That's 1/3 of a second.
Now recall that the longer the buffer size, the slower the client runs.
Oh.
Because that's an extra 20 simulations of prediction. Which is fine.
Yes. That is interesting.
Yeah, it sucks that those two actually like oppose each other. I'm curious about turning it down to 30, because 30 actually effectively gives us a buffer size of 20 because you have twice as long to process those 10 frames.
Yeah. We hope. Right.
Yeah.
So simulation period, it's 2 out of 60.
Sure.
I think that's it. Is that it? Is this going to work? It's funny. These two constants actually deserve to be next to each other because they really do dictate a lot about how the game logic works.
It's kind of the entire game.
Yeah.
Right there.
This is God right here.
And if I was going to suggest something for us to work on, I'd actually be really curious about what a client catching up looks like, because at a certain point I should be able to say, like, man, I lost the server, like, you know, rubber band me into the present, and like, let's just get back at that.
Dominic, you're asking the hard questions, but I know, like, I think I know what you're getting at here.
Mm-hmm.
What that would involve is the server sending a snapshot to that client that's lagging.
Now, does it require sending a snapshot, or does it require just because the client is processing all the server input? Why is it too slow though? It's because it's taking longer than the frame time to get through its cycle.
Yeah. Did I close Ngrok? Ngrok should still be rolling, right?
Oh, Ngrok just keeps going. Yeah.
Okay.
Ready?
So let's join. Yep.
All right. All right, I'm good.
I'm at 30, and oh my god, this is fine. This is totally fine.
Yeah.
Wouldn't it be cool if we could actually shoot each other? Your bullets are getting a little bit swallowed. I don't know if you can see this on the stream, but your bullets are they're rendering way ahead of your tank, which actually makes sense because we're I lost it.
Damn.
I just lost it. Yeah.
Weird.
Yeah.
So I noticed that your motion, I mean, this is tough because I'm watching you via Zoom and watching you in the game.
Yeah.
But it seems like you loaded the game up far ahead of me. I think we still have a local client frame count issue.
Okay.
Because your frame counter started when you loaded the page, right?
Yeah. That's right. So we need to fix that.
Yeah. Let's bring that in and see what we get.
Sounds good. Okay. And we don't have hot reload anymore, right? So
that's okay.
Okay. No. All right. So that was in main.tsx, right? So basically, what you're saying is that the update shouldn't take a frame number anymore, right? The client should just know what frame it's on.
Yeah.
Right.
Yeah, and at some point it should be able to set itself to 0 with the start message. And I think that'll actually, I hope that brings us closer.
Yes. We could call this the prediction frame, but whatever. It's the frame that the simulation is running on, right?
Yeah.
And basically, I think we just start incrementing it when we're running, right? And I don't like default case game state running, and we'll have to figure out what to do about you died and whatever. Again, like I actually think that these two are two top level modes, and then this has like a substate. And then in here, we can basically just increment the local frame counter down here, right?
Oh, yeah, totally.
This dot simulation frame. Is that what we're doing in the server too? Are we? Yes, it's exactly the same code.
Okay, perfect. That feels even better.
And then, so frame here is now this dot simulation frame, right? And we get rid of it as an argument. And main.tsx no longer passes it in. Okay, so we let that rebuild for a hot second.
Sweet. Okay, now we should be able to refresh and get at it.
Or soon, one second, the server will basically pop up a message saying that it's running.
Cool. Yeah. Sweet.
We basically had queued a... The sort of like rebuild thing is smart enough to know that if you're in the middle of a build and you receive a bunch of like file changes, it'll only rebuild once.
Oh, that's great.
Yeah. Or I hope, right? If this happens again, then I'll eat crow.
I would expect it to. Okay, great.
Okay.
All right, I refresh.
Yeah. Okay, so yeah, you started moving like almost right away, which is good. Yeah.
And so did you.
And then I just finally fell behind right now.
So fast.
Yeah. But it was actually, I would say it's probably over twice as long as before when it was at 60.
Dang, okay.
So I think the buffer needs to be higher. Although, I don't know, like if I'm, sorry, if my simulation is running permanently at a slower FPS than yours, then I think I'm just hosed, right?
Right, you're screwed. And I'm running, my update FPS is 30. Like
so
flat,
is this
flat
a Safari
30.
thing? Let me try running in Safari then.
Try it. I'm in Windows Firefox, so see if you can get a better performance out of Safari.
Oh, okay, yeah.
I could hamper myself with a local Safari though, or local Mac.
No, it's fine.
Whew, you got that update.
So this is just not going to let me in, I think. Yeah. So I'm going to go ahead and terminate that. And wait, Safari can't connect to the server localhost?
Oh, there's no server localhost right now.
Okay, so I restarted that, and yeah, I still can't connect to localhost.
What?
Oh,
yeah.
What the hell? That was weird.
Okay, here I come.
Yeah, my update is now host. Yeah, it's weird. It's funny. I'm just sort of like perma 2 or 3 FPS behind 30. Maybe it's just that I have 1 fewer CPU cores than you or something like that, or multiple fewer.
It's really strange though, because when it was set to 60, you were just sort of hanging out at like 55. So like, it's evident you can simulate 30.
Yeah, that is true, right? So
the hell.
I think it's just, yeah. So we probably have to do just something much more sophisticated to make sure that.
And your frames ahead of server has gone back to positive, and you still can't move.
Oh, I can move now. Yeah.
Great. Oh yeah, yeah. You moved instantly. Until you can't
And
again.
it's still positive, but for some reason I still can't move. So something about my frames ahead of server is weird right now.
Yeah, and it popped back negative for you. So.
Okay. Yeah. Oh, you know what it is? It's just a running average over 3 seconds.
Mhm.
So it's going to be like a lagging indicator.
Mm.
Maybe I need to change the window in which we're sampling.
But essentially, when I stop, you catch up. And your frames ahead of server is actually like reapproaching. Yeah.
Yeah. Unfortunately, I'm kind of locked now because I think you're far enough ahead. Since you're the leader and the server bases its simulation on what the leader is doing.
Oh, interesting. Why am I the leader? Because you connected first.
You're connected first, but your simulation is running the fastest. So when I say leader, I just mean that you are the one that is setting.
Right.
Oh. You are the one that's setting.
No, that makes sense. Oh, but you're about
this max receive client frame is always coming from. It's always being set by frame end messages that your simulation is sending because you're running so much faster than me.
Yep. No, that is totally true. Oh man, and you're so close to approaching being ahead of the server again. Dang.
Yeah. So what do we do about it? What does yours say? Does it say?
Mine says 0.01.
Okay. That is a weird number. I think I did the math wrong.
That is a weird number. So, because that's trying to tell me that it's. I noticed this was another one that had 1 over on it. I wonder if that's.
Yeah. I think that's just straight up wrong, right?
Mm-hmm.
I feel like my neighborhood has like a preponderance of very loud vehicles driving by it.
I've noticed that. Yeah.
So maybe there's just a person that lives near here that has such a thing.
That's really funny.
Motorcycle?
I
wonder.
It's a motorcycle or like maybe a lifted truck. Really got to go do some farm chores.
I think this 1 over is just straight up copy pasta.
I think you got it from Update FPS. Yeah.
I did. Yeah.
Okay, so let's wait for that to rebuild.
Because your frames ahead of server should be like 10, right? It should be basically that number.
Should be, yeah. And I see 0.01, which is also 100th.
Should be building now. I wonder why.
I think it built. Did it build?
Oh, it's building now. Yeah.
Cool.
It's just interleaving a lot of the output. Yeah. Oh god, dumb. Because this one like yarn dev call like interleaves the client build, the server build, and the active server. I like got this close to writing like this fully featured like logging suite, just like I wanted to like log different content. And I was like, what the hell am I doing? It's exactly the reason why we're doing this on stream, is to just constrain those tendencies of mine to just like work on random procrastination.
That's so funny.
Stuff. Do you know what I mean?
Yeah. Oh my god, dude, that's hilarious.
I feel like you don't fall afoul of that kind of thing. I feel like you're pretty on point when you.
The random procrastination stuff, I get bored with it. It turns out.
Yeah.
Okay, cool. My frames ahead of server is 20.
Oh, so
going up. I'm well past 10. Approaching 30.
Yeah.
And you're in a solid like barely 1, and now you're negative.
Yeah, now I'm negative. Yeah. Okay, so this makes a lot more sense, right?
So
now that I'm negative, I can't move.
So I'm Speedy Von Client. I feel like I shouldn't be able to push this far ahead. Like I'm at 50 ahead of the server now. Yeah,
and I think in reality you wouldn't if we had tighter control of the FPS, right? Actually, here's an interesting thing: is that maybe the server shouldn't be on a set interval at all, and it should just be it should just be in a for loop. like literally a busy wait.
Ooh, you're gonna eat your whole CPU.
Yeah, well, maybe at the maybe we just do like a set timeout that's like a really small number.
Well, could the server run twice as fast and somehow just be like
it can run twice as fast, right? We have that limiter there, right?
Yeah.
The idle thing. Okay, so that's a great suggestion. So server main.
But yeah, now I'm 100 frames ahead of the server. How do I?
So what we want to do here is run twice as fast, right? We're going to call this twice as fast, but the actual like delta, it's probably silly that we're passing in the delta every frame. It doesn't make sense anymore, right? Because we're assuming a fixed time step at this point.
Yeah.
Right. Yeah, and you can see locally here, I don't know if you can read this, but I'm just like slowly going, like increasing my frames behind.
And
25, 26.
But is this because of me? Like I'm setting the high water mark with a buffer. But in fact, you could keep up with the server.
It's allowing the server to continue to like attempt to catch up to you because of the high water mark, and then yeah, it is sort of a death spiral for what's running in my browser on my side.
Yep.
Okay, so if we reload,
cool.
Your frames ahead of server now should probably stick. Oh man, I just immediately lost it.
Interestingly,
yeah,
it is now stuck at around 15 frames ahead of the server.
Okay.
So it stopped going up because the server can keep up with me.
Yes, exactly.
Your client can't. It looks like.
and it's just like it's losing out massively. And you know what it is because the server's running twice as frequently, it's sucking CPU from the browser right now.
Correct.
I think that's what's happening.
Though your update FPS is still just like 28. It's like fine.
It is fine. I agree. It feels like we're losing frames faster than... Well, it's like 1 frame per second behind, right?
Yep.
Which means that every second we lose a frame.
Yep.
And it kind of looks like that's how quickly the FAOS number is going negative, right? It looks like it's roughly 1 per second.
That does seem correct, yeah.
Yes.
And
wow,
so
our basic arithmetic is on point tonight.
And so it's interesting. So I'm a constant 15 ahead, but since the server now runs twice as fast and idles, it's fine. It just keeps up with me.
Yep.
Okay.
Because it's just trying harder, right? And because of simulation on the server, it's not.
Would that we could all
anything.
Just try harder.
Yes.
just turn me up to ×2, please.
I need my browser to try harder. So, is there like a time dilation kind of thing? Can I tell the client, hey, you're lagging. You should simulate faster. In fact, I actually think that's what that Overwatch video talks about a little bit. Is it says like if you miss, like basically, I think what they say is that in the server code, if this happens, we figure out which client it comes from, and we say, hey, client, you are running way too slowly right now. You need to catch up, and you need to start running your simulation more quickly.
Yep.
And that's complicated.
It is, but maybe we could add to our debug output the expected simulation period for each client. And we could actually say, like, we could give your client permission to run at 60 frames per second until it gets to 10 frames ahead of the server again. And that should still, like, since our simulation is deterministic, that should still be totally fine, right?
Yeah, I think you're right. So, okay, let me pop out of this and just try to think about what you just mentioned. So I think what you're saying is that on the client side,
Our timer just became a variable on this side too. Essentially.
Yes. Yeah, I see what you're saying. She's basically saying that this shouldn't be outside of the client.
Yes, correct. Yeah, we gotta pull that in. So update needs to reschedule itself, I guess. I mean, it's not fine. It's not that hard.
It's fine.
Yeah.
Yeah. Well, then it does mean that update appropriately should be receiving this as an argument because it can change.
Right? Yeah, exactly.
Or there's just a mode. There's a mode flag that says, are we in 60 FPS mode or 30 FPS mode, right?
It's interesting because it's like permission to schedule faster. 30 is your target, but occasionally we're saying like you're missing 30, go to 60. I worry about the DT changing because we still want a simulation that simulates each frame is 1/30th of a second. But we're telling the client to schedule itself to be like, listen, like pick up the pace, like there should be like 10 milliseconds of pausing between these frames, and actually like you're having trouble. So like, can you do a couple more frames for us faster and get them in the network a little faster so we can keep you up to date with the other ones? So it's like,
here's what's really hard is that as soon as that when you said that, what I thought of is if the DT changes at all, then it's no longer deterministic because we get into the realm of like floating point error, right?
Right. So update, like simulation period is a constant. Like 1/30 is the constant for every simulation. But the second part, line 54, can be variable without fucking up that constant.
So here's the thing that we could do is we could say the simulation period is 1/60, always fixed.
Okay.
Every client will do a set timeout of half of that, or rather twice that. So every 30th of a second, and then run 2 simulation frames. During that time.
Oh, interesting.
And so it'll feel like it's 30 FPS, but it's actually each time we call the update, we're basically saying, well, run two things, and that's just so you can kick up to a 60 FPS update. Does that help? It might help.
One of the things that's interesting about that too is that it lets us like, instead of doing 2 per cycle, you can actually like 5 per cycle. And sort of, I feel like in a network thing, it actually might be nicer to send fewer batches of like 5 simulated frames of input at a time, back and forth.
Okay. Let's think about this one then. Okay, so the simulation period is what we're going to say is it's always going to be like fixed, right? And so we're back in the realm where I think we kind of agree that this can't be passed in. This has to be like constant everywhere.
That has to be constant, but I do think rescheduling can be faster. The same way the server can run way faster, we could reschedule ourselves as fast as we want until the server says, okay, cool, like chill out again.
I agree. Okay, so on the client side, we basically need like a what is our, like how quickly are we rescheduling ourselves, and then I think directly related to that is how many simulations are we running every time we're scheduled, right? Does that
simulations
feel right?
Are we running every time we're scheduled? Oh yeah, that does.
Yeah.
Because the server could say run 2 at once. That's your reschedule multiplier. Totally.
Yeah. So should we just store that as one number then? Is it like, or is it 2 numbers? And it's just totally variable. I mean, they need to be related to each other, or else like your local simulation is not going to feel like it's running at natural speed.
Mm. Yeah, I think. I think it's just one. It's just, yes, number of simulations per frame, and it defaults to 1.
Updates per we need kind of like an outer notion of an update. The innermost notion is a simulation.
Mm-hmm.
And then the thing that contains a simulation, or potentially multiple simulations, is an update, which is 1 frame.
So is it simulations per update?
It's frames per update, I think.
Frames per update?
Because a simulation can happen multiple times in a frame because you're simulating predicted input, you're simulating server input, that kind of thing.
Yep.
So it's like frames per update number, right? And I think we do have an update, and this becomes like frame, right?
Mm-hmm.
Or frame tick. A lot of games just call that tick.
Yep.
Right. So here, what we're basically saying is for let I equal 0, I less than this dot frames per update. We'll call it ticks per update, right?
I feel like it's ticks per update now, yeah.
And just for now.
I was just say it's simulation period, yeah.
Just for now.
Mm-hmm.
This dot tick. Right. And then let's call this ticks per update. And
I know you say just for now because, like, clearly that's just a constant that lives in tick. And tick is, like, we don't need parameters for it, which will be nice. But...
And then this schedules itself, right?
Yes. Though, I think that doesn't really matter anymore. The outer loop doing it.
But we need to modulate it, right? We need to add some logic here that says, okay, well, what is ticks per update going to be next time, right?
Mm-hmm. I was thinking that, like, this gets modified by a server message, though. Like, a server says, like, speed up, and we just increment ticks per update. And maybe it says speed up until you get to frame, like, 1,000.
Interesting. Let me ask you this. Because the WebSocket is our mode of communication, is it enough for the server to simply send its normal updates? It's not, because there could be no input at all, right? There could be no input from anybody, and you're not going to get anything from the server. So it needs to be explicitly okay. So I agree with you. Okay, but the update still needs to schedule itself, right? It still needs to say, okay, I need to schedule the next update, right?
I mean, just it doesn't have to just because the outer loop does that right now. But yeah, I think we could.
Well, we should get rid of that because it needs to change, right?
Well, I think by having ticks per update be the thing that changes, you don't need to change this anymore.
Well,
it's like one or the other, right? I think my original suggestion was that we change this value, or sorry, yeah, we change this outer value and leave simulation period the same. But essentially, the outer value doesn't matter because the server is going to say, like, too slow, more ticks per update. Our update just keeps running at a constant frame, a constant period. Maybe tie in simulation period and the reschedule period to be in the same number is just confusing, and, like, we should just pick a new value for that.
Yeah. So let's try and identify what the actual problem is going on right now.
Yeah.
And the problem I would claim is that set interval here, like we have enough CPU to run the simulation smoothly, because when this was 60 FPS, this was running at 58 FPS. It's not like the code that was running in here was slowing itself down.
Exactly.
So it's actually a scheduling problem, right? It's actually just that like set interval couldn't hack it because there was other stuff in the JavaScript event loop that was like getting in the way, right?
Yep.
There's just other stuff in the event loop that's happening here that is preventing it from hitting 30. So that means that in order for us to compensate for that problem specifically, we need to be just like prioritizing the tick so that it literally gets called more, because we're just like losing it in the gaps, right? It's the gap time that's killing us right now.
Absolutely.
So I think what I'm saying is that like we need to go from a mode where we have relatively big gaps, we're simulating at 30 FPS or whatever the baseline FPS is, and doing like 2 ticks per simulation there. And then if the client receives a message that, hey, you're falling behind, what it'll do is then say, okay, you know what? Just run 1 tick for each of your scheduled updates, but just schedule that update twice as frequently, under the assumption that the problem is the gap time, right? Because if you schedule the update like twice as frequently, the gap time is going to become less of a problem.
I see.
Yeah.
Okay.
Does that kind of make sense?
Yeah. That's really, really interesting. Okay.
I'm basing it off of your observation that when we were running at 60 FPS for the update, my client was like kind of able to keep it up, but it was just like 2 frames off.
It's always like 2 frames off. Yeah.
Yeah. So it's not a problem that this code, like this update code, is like just like simply just like burning the CPU literally past the time it can schedule itself again.
Correct.
It's actually the case that it finishes with plenty of headroom, and it's just this whatever mechanism behind the timeout or the interval is preventing it from getting there again, right?
Yep. Yeah, it's really interesting to see the number actually be 30 on my side.
Yeah. Okay, so what that means to me is that we would do something like set timeout this dot update and ticks per update. It'll be like simulation period s times this dot ticks per update.
Now, I recall one of the reasons that we sort of went to the outer loop is that this gets scheduled after a whole bunch of computation and is already going to be off by like however many milliseconds it took to run the simulation or the tick. So scheduling it first is one option.
So let's schedule it first. Then.
Yeah. And the other option I think we have is to try to measure, and I don't know how viable this is in JavaScript, but to measure how long we were spending and to schedule it like one update interval minus however long we just spent. And I don't know if that's better or lets us be more dynamic.
Right. And I think that's definitely possible. Do you remember like we had mentioned that Eric had posted the message in one of the commits that we had? He basically said that like Chrome actually tries to do that for you as a value add. Like it basically does that. It knows what the interval was doing before. It kept a history and said, okay, I can tell you you're falling behind, so I'm going to try to like even it out for you.
Oh, goodness. Okay.
Yeah. And I think it's becoming standardized behavior, but I'm okay before we run potentially expensive. Yeah. Game sim, right? And then simulation period times ticks per update means that we're basically going to give the start of the next update this amount of headroom. Like it's like don't run until this amount of time has passed, and it makes sense because like we want more time to pass if we're doing more ticks during this current update. Right?
Exactly. Yeah. No, I like this. This is a very cool way to sort of flex it out. And I think you're exactly right, which is that just choosing to run them all as fast as possible in the period actually buys clients that are like laggier more headroom, which is really cool.
Right. Okay, so then this dot ticks per update right now is just going to be 2. So where this is like technically
it's 2 and our simulation period is a 60th.
Yeah.
And
so
it schedules it every 30th. Yeah.
Every 30. Yeah. Yeah.
Okay.
Great. And you know, it's funny. No, it doesn't matter.
What you think?
I was trying to think because, like, when you were working on that other display and it was running at 30, it was rendering at 30 FPS.
Mm-hmm.
I think our render and update frame rates are totally independent right now, which is good.
They are, and they feel. I don't feel like render is impacting game update at all, which is really nice.
Yeah, it's nice. Okay, so what this means then is that in main.tsx, the client update now just becomes this, right?
I was
We no
tempted.
longer have a simulation loop.
Yep. I was tempted to see if I could turn this thing up to 120 hertz, but then I didn't want to mess with the stream.
Okay.
But that'll be a fun test on our monitors.
Yes. Wait. Oh yes. Yeah. Totally.
Mm-hmm.
Do you have an issue where when you connect you have the Dell monitor, right?
I got the same one as you. Yeah.
Yeah. Do you have an issue where you'll sometimes connect to your Mac and it'll connect at 30 hertz rather than 60?
Yeah, all the time. I hate it.
I don't like. Basically, you just have to unplug it and replug it in, right? Or turn it off, and turn it back on, right?
You got to do some shenanigans. I have.
Do you have something in software that can do it?
No, but I can open up system preferences and you can see what it thinks its refresh option. Yeah, go to system preferences and displays.
And then hold option or something like that.
Yeah, you hit option. You hit option when you click on scaled.
What it?
Hit option again. I don't see the better interface.
I only see detect displays showing up here.
No, hit option when you hit scaled again. Maybe you have to click it twice.
Oh yeah.
And then show low resolution modes will give you the option to see your refresh rate. There you go.
Wait, where is the refresh rate?
Below the.
Oh, right here.
Yep.
What a bonkers UI this is.
The monitor is reporting some very strange nonsense.
And so what you're telling me is that it only thinks it has 30 hertz available sometimes.
Yeah, and I go in here and I can check. Sometimes you can actually upgrade it from there, and sometimes you can just see like I gotta unplug it because it doesn't think that like the full range exists, and I just plug it back in again and it works.
Right.
It's very annoying.
Wait, how come this isn't totally hosing me right now? Am I actually running at 1920 by 1080? I feel like
you totally are.
Oh. Okay.
Don't set default. Don't do that. Oh, is it a 1920 display? Might be.
No, I mean I'm running on the same monitor that you're running on right now. So.
Oh, does it default to 1080p?
It should be 4K. I'm actually very confused about my resolution right now because I think it's like Retina 1080p, right?
Oh, maybe so. Because you're zooming at 100%, and you're definitely still like a small window. So
okay. It's amazing that like I don't understand this stuff whatsoever. It's not amazing. Why should I expect to understand it?
It's kind of nonsense. It would be very interesting though if you could do non-Retina 1080p. If your computer would be faster for pushing literally half as many pixels.
Right.
I've rezzed down sometimes for performance like that.
Interesting. Yeah, because I know I upscale in general. I upscale the UI in general.
Mm-hmm.
But I always assumed that it was. I guess I was under the assumption that it was literally drawing larger graphical objects rather than rendering the same virtual number of pixels, but then like doing whatever retina magic makes it retina. Do you know what I mean?
Yeah.
All right.
I'm not
Fun
sure.
little distraction. I'm going to go ahead and run this and
Okay,
see what
cool.
happens. Let me make sure I haven't broken anything.
I'm going to connect from my iPad just to throw a wrench in the works.
Oh, very interesting.
I'm curious what the FPS will be. Because the iPad has a 120 hertz screen. That's how I'm going to test it.
Nice.
Oh man, I don't know if you can see the glowing cat eyes behind me, but it's pretty solid.
I can't see the glowing cat eyes. I can't see the cat, though.
Every time...
Oh, yes, I can kind of see it. It's like one yellow pixel. I guess I could increase the size of your... Yes.
Oh, man.
Full tab here. Yeah, there we go.
Every
now
time...
you're like my whole monitor.
Every time he looks at the ring light, it is extremely weird.
Cats are... They're kind of little demons.
Mm-hmm. The best kind of little demons.
Exactly. All right, we are ready to roll.
All right, hitting it. Oh, interesting. My update FPS is just off the charts, and so is yours.
Mine is off the charts, but it's super jittery, which means I'm still behind the server.
Damn.
Well, you know what it is because you're way ahead, right? We haven't slowed you. We haven't
slowed me down. My frames out of server
I haven't sped myself up, right?
Oh, right, of course.
And the server will basically just keep up with you, right?
Mm-hmm.
Unless we increase the buffer.
This is wild, but this thing plays so fast. My update FPS is 100. Oh, yeah, because we're doing 1/60th twice per second.
How are we doing FPS again?
Crud.
I think we're assuming each update is happening at a certain time, right? Tick update frame duration sample now.
I give you a totally subjective experience is that this thing feels like it's playing twice as fast.
Did we... I think you're right. I think that's true. It looks like you're running twice as fast.
Oh, yeah, you can see me fucking around, of course.
Did we bork this?
That seems like it should be correct. We tick twice. We schedule 1/2.
Yeah, basically we increase the gap between updates, right?
Mm-hmm. Oh, it's 1,000 times simulation period. That's a very tiny update tick. Because that was on our outer loop before.
Hilarious.
Love it.
Come on, ESLint.
Mm-hmm.
And then we're just limited by what the server can do, right? At
yes.
that point.
Mm-hmm.
Yep.
Oh, goodness. My unservered FPS is a solid 400. So that's cool. Wow. It's actually a really cool game when you can run around the map this fast.
Yeah. Well, I think what we're learning that, well, at least because our CPU load currently per frame is relatively light. It should be, but...
Right, yeah.
Oh, I took that water down incorrectly.
Oh, no. Sorry, Jeff.
I'm just going to spend the next 15 minutes gagging. Don't mind me.
Every time I do that in public now, I am just so embarrassed. Or even on a Zoom call with like coworkers, I'm just like, I swear I don't have the thing. I'm sorry. I drank water wrong.
I think it's these pint glasses, right? They're just quite large, and then basically by the time you've gotten to lower than half, the distance that the water needs to travel and the angle that you need to hold the glass, all those things.
It reaches like, terminal velocity.
Exactly. Yeah. Exactly. All right. This is more like it. I think I'm at a solid 60 FPS. If you reload.
Let's do it. Here it comes. Oh, wow. Okay. Yeah, just kind of hanging at 60.
Yeah, I just fell behind, which we expected. My FPS is just garbage right now. It's
garbage, yeah. Is it going to catch up, though?
No. Well, it's not going to catch up because we haven't written any catch-up logic.
Okay. Yeah.
And I'm currently approaching 300 frames behind the server.
The iPad is unfair. I'm gonna stop doing this.
Oh, it's cool. I'm actually. It's actually really entertaining to me that the iPad is so much faster than your computer.
The iPad is even faster than this gaming PC I bought. So that's something.
And so now I'm in the land of pure prediction, running at a solid, just a notch under 60 FPS. This is what we expected, right?
Mm-hmm. Oh,
I just saw you drop out as well.
I dropped out is why you're able to, yeah. Interesting. Okay.
And these idle messages are interesting.
Mm-hmm.
Like this last idle before you dropped out, 716 frames.
Whoa, that's when you caught up. Oh, fucking wild.
Yeah.
You caught up, and it couldn't read a new simulation from me, so it crashed?
Yeah, I think that's right.
Okay.
Yeah.
Cool.
Okay.
So we're going to insert a message when we start throwing out client frames, or maybe even like slightly before that if we can.
Yeah. So game.ts or server. So this is interesting. We need to send a message to a client saying, hey, you're kind of in the red zone right now. You should probably speed up.
Mm-hmm.
We also need to tell the client, hey, you're fine. You're good. You can go back. You can resume your previous chill.
Yeah, because what is the consequence of this is that your updates to the server become batched, and your granularity of responsiveness is kind of like degraded. Like if you get really far behind and we're like, all right, simulate 60 really fast and hand it to us, you've had a whole second of like not interacting with the game world essentially.
Yeah.
So that's the cost. Okay.
So I like intentionally chose not to factor this out, but this is one of those things where like, I knew I was going to need it, but I'm not going to factor it out. I'm not going to do it now because I'm trying to prevent my like over refactoring, over optimizing kind of personality. And what that is knowing which frame each client is on, right? I kept a high watermark.
Mm-hmm.
That's this.
Mm-hmm.
Probably what this should just be is the max of multiple values of what we think each client is at right now, right?
Mm-hmm.
Yeah. So client connections maybe becomes a little bit more interesting. Becomes something like this. This becomes just clients.
Mm-hmm.
And then where do we actually use this? Clients as an array. Great. So connections there, and then what's the frame? -1? This is either -1 or 0. I can't tell what it should be.
I like -1.
Okay.
I don't know why, but I prefer that as an incorrect value. C did that to me.
Sure. This is client.connection.consume.
Mm-hmm.
And then if it's frame end, then we say that this.client.frame equals message.frame. And then the high watermark still is the same, not this.client, just client. And will this update correctly? This feels a little bit weird. We're iterating. It will kind of update correctly.
Mm-hmm.
Yeah, it's fine. Generally, I don't know. For some reason, over time, I've become really wary of code like this. It's like we got a pointer to an object, and now we're updating it.
Like in its own loop, you mean?
Yeah, that's fine. The other thing we would do is just like iterate over the indexes, and then it bothers me less if we did something like this dot clients I dot frame equals that, right? That feels a little bit, yeah.
Right, because you're always getting a clean index into the object.
Exactly.
Mm-hmm.
Yeah. Whatever.
I'm with you, though. I feel it.
Okay. Thank you. You're always so charitable. I like that.
I think you just do things slightly more correct and thoroughly than I do. So
you're too polite, Dom. Tell me what you really think. All right. I already lost our train of thought. We were going to figure out a way to tell the clients when they should go to like overdrive mode, right?
Right. We want to send a message when their frame falls too far behind the max receive frame, I think. Is that the goal?
Yes.
That's our delta. We're like, you're 20 behind the max, like catch it up.
So if this dot max received frame minus client dot frame, it's going to be at least 0, right? If it's greater than some number, what's the number?
Should we use the buffer value to start with?
Yeah. So basically, are we dropping your frames at this point? This dot max receive client frame.
Sorry. This is the delta, so it would be.
Yeah. Sorry, I just picked that one.
It's okay.
In frames behind client.
Yeah. And do we exit early, higher up in this loop if that's?
We did. Oh yes. So we should not ignore this, right? Maybe this needs to actually happen. This needs to happen above. Okay, good. All right. Fine.
Also, this is like just at this point we can just send the message.
Oh yeah, so we don't even really need to know what frame they're on.
Yeah.
Is all the factoring that I did above pointless?
No, because I was going to say the code you were putting in could be the place to send the message to stop running fast. Like once your delta between you and the max server frame is less than the buffer, you can chill out again.
Is it fine if I maybe put this here?
It's probably okay.
And then what was the other code that I got? Wait, where did my? Oh, you know, I got rid of it. So what I want to do here is I want to add that line back in, which is client.frame equals. And notably, I'm only updating this when we get the frame end because I want to know when the client's fully done. I don't know if that's super significant, but it seems nice that we know that like we're not going to get any more messages from the client for that frame.
Now, so framing is what we send just so we have a heartbeat, but this could run on every message essentially. And in fact, maybe it should because if we're working on the input message and that's what we have, we can also say that like you're too far behind pretty easily, right? But I guess we always have a frame end. Maybe it's nice to just hang it off of that.
Yeah. Okay, and then probably what we need to do here is we say if the message type is not this, then probably what this should be is store message grouped by frame, but don't worry about frame end messages. Special case here is a smell. It kind of feels like it shouldn't be even in the same group of things, but whatever. Okay, so you're saying basically at this point we should do some logic, which is here.
Yep.
If the difference between the high watermark for all clients and this client's frame is greater than min frames behind client.
Min frames behind client, yeah.
Then client.con send, and we need a new message type, right? So server message
Mm.
I
Maybe
don't know what to call it. Like,
well, we could
hurry
also
up.
we could do set ticks and hand it a value. We could hand it 4. We could hand it 2 to throttle it back down again.
The only reason why that
Would you prefer like the speed up and like return to normal as like 2 separate messages that are harder to confuse?
it's just that the server doesn't know what ticks the client is running at initially, unless you make the assumption,
Mm-hmm.
and
So
you have to like keep state, right?
that's fair. So it's really like it's like go into hyperdrive and chill are the messages.
Yes.
Okay. Yeah.
Adjust, update, and we could say slow down or speed up could be the adjustment,
Oh, yeah, okay.
or it can just be like speed up, slow down.
I think that's fine. That'll be
Okay.
easy to reason about.
Okay. All right. These are going to be really cool messages.
This looks so much like Redux.
Well, maybe they're onto something, right?
They are. They totally are.
And then nothing.
Mm-hmm.
I think the name scheme that this should be is server message speed up, but I feel like I'd have to change a lot of code, so I'm not going to do that right now.
Yeah, let's do that later.
I think we discovered like 5 different naming schemes throughout our messages. I think the client ones even have it like.
Oh, I remember. Yeah, we were
client message.
we were writing at some point. Like we did both directions in one function. I was just like, oh no.
Yeah, and I even think the enum value was player move as well, right? Like it was just like.
Yep.
Like subject verb rather than verb subject. Yeah, this is great. This is the joy of programming right here.
Oh yeah.
Slow down. This code is great. I love this code.
Mm-hmm.
It's literally start game. Yeah, verb, object, verb, object, verb. You know what? It's fine.
Yeah. So is there a clean code philosophy that would have something to say about this? Probably, but I don't care.
It is a very intricate subject, actually. Server message type speed up.
Mm-hmm.
So here's a question for you, Dom.
Yeah.
When should you send slow down?
I was thinking, what if we never did? For now.
That's fine.
Yeah. But also I think once you catch up to like
it could become an arms race, right?
Yeah, but like maybe like when you're greater than the delta, when the delta between the leader and you is like half the buffer size, so it's kind of like a weird rubber band between.
Oh, that's totally fine. I like that a lot, actually.
Because that'll like you should just speed up and slow down a lot, but like it's okay.
Yeah, we might end up in getting judder, which is that like the render on your side might be weird because you're constantly switching back between frame rates, and where the render lands might be inconsistent.
Yeah.
I'd rather just solve that when we get to it. That's not the biggest problem for us.
Also, the render already is inconsistent because it's not hitting 60. So, are we kind of already there?
Yeah. Okay. Yeah. So is then
what is
there a different thing that we should say, that if you're less than half the number of frames behind leader, you can slow down again?
Yep.
Okay.
And it's weird because we're probably going to send the leader a slowdown message every time.
Yes, unless we know that they're the leader.
Yeah. Or if we count who we told to speed up before we tell them to slow down again. But like,
Yeah, we could. Yeah, I guess we're trying to avoid keeping.
I don't want to hold on to
that,
the state. Yeah.
It's not the worst state to have because if you're behind, if you're like second place and you're always like one frame behind, you're going to be receiving this every single frame.
Yeah.
You know, it's not the worst thing in the world. Let's just do it and let's optimize it out later.
I was gonna say we could still just not send slowdown because it'd be cool if we did speed up now and got you and we could run the game together. Because then slowdown is an optimization, right?
Correct. As long as it doesn't become an arms race where I actually get ahead of you. Does that make sense?
Right. Yeah, that'd be interesting.
Okay.
Let's see though. I'm curious.
Let us see. Okay. So we send a speed up message.
Mm-hmm.
And then in the client, we currently process this as part of the tick, which is fine. Because we don't read this until the update here. So basically, what we're just saying is like, in the tick, we'll consume the server messages, and here, if it's frame update, okay. So we just need to make this a switch now, right?
Yep. And do we need to do something like next tick or next frames per tick? Next ticks per frame? Next ticks per update. Ugh. And the reason I say that is I worry about modifying that value if you're in the loop and you suddenly schedule like a second tick immediately. Maybe that's okay. Or a third or a fourth tick.
Yeah, I know what you're getting at.
Mm-hmm. That's good because I said it terribly. Oh, that break is.
Let's try and talk through that.
Okay.
What is with this indentation?
Your break is one line down.
I mean, normally does this kind of thing, right? I feel like.
Right, your break is just outside the case statement.
I think that's fine, right?
Not when you give it a block.
I mean, it's fine up here, right? Okay, it formatted itself finally. It was just my yeah.
Wait, that does work?
Yeah, I think that's kind of the way I like doing it. Is that weird to you?
No, I didn't know that you could do that. That's great. I thought when you changed it to block syntax in JavaScript, it required you to put the break in the block. No, wonderful.
Cool. Just so we don't forget.
Today I learned.
Remember to also send slow down. Gosh, it's so funny how we're like all the stuff that was in that lecture, that talk about the Overwatch multiplayer. I like listened to it and I'm like, yeah, okay, cool. And but it was very much of the kind of like I kind of get this, but it's also kind of just words right now. And I'm like so appreciating the value of it right now. It's crazy.
I'm honestly not sure what I expected from that play, but it's weird that is literally every chunk of that. Yeah.
Yeah. Okay, so if it's that, then this .ticks per update becomes 1. And
that's perfect. Right, because we schedule it twice as fast.
Yeah,
okay.
It'll just get scheduled twice as fast.
Cool.
All right. Why are you not formatting? Oh, it's formatted.
Mm-hmm.
This just looks really weird.
Mm-hmm.
Should I get rid of the blocks? I'll get rid of the blocks. Come on, you can do it. There we go. All right, that looks a little bit better to me. Okay.
Right. Kick the
this
server.
Should probably work, right? This should probably work.
Let's find out.
I think it's building.
Oh, I love that it actually is just kind of catching up behind us, and like that's fine. It's not the fastest, but it's all right.
I mean, it took 10 seconds to calculate the map.
Oh, yikes.
There's a certain point where we can't bundle these. They just need to be. They need to be files that we read off disk, or they need to be files that we pull off the network, right?
We should.
Well, man, it's building way too many times. So there's some bug.
There we go. Okay. Yeah. All right, ready?
Want to try reloading?
Yeah.
So your FPS should still be 60, right?
I reloaded.
Con.send is not a function. Dang it.
It's not?
Where did I screw this up? Yeah, there should be a bunch of TypeScript errors in here, right? Oh. Rufus has gotten really good at the...
Oh, I love it.
The little squeeze toy. At first, he was a little bit reluctant. Like, he didn't quite get it. And we'd squeeze the turtle. And I just expect dogs to just flip out when that happens. And he was kind of like, well, what do you want me to do? I feel slightly like I'm being condescended to right now, but I'm not sure. What do you want me to do right now? And now he's just like ape shit with the turtle. The squeaky turtle. All right. That isn't a client. Thank you, TypeScript.
There's the TypeScript errors. Yeah,
yes.
It's great.
You're slow, but you are reliable. Should be building. Should be building.
I was going to say I should really push through that change I made to the map to only define entities that we use and not a null array of 4,000, because it seems to have broken JSON.
Yeah, we've stretched it to the limit here. Okay, I think it'll run now. I'm gonna reload.
Oh, yep.
Cool.
Okay.
I'm stuck still.
You're more behind than ever, in fact. Interesting.
Yeah. Did I receive speed up?
How can we tell that?
I can console log.
Okay.
I'm going to receive speed up every frame, right? So we should probably recall state. Speed up. One thing we could do is we could call this a tick FPS, and we could have the update FPS as well. Why don't we do that?
Okay. I have a thought. The speed up, I think. Are you sure we didn't speed up in the wrong direction? Because we set it to 1. But in fact, it'd be really nice if you could run 6 frames in one update and then schedule the next one. Because I think you could run them faster than... I think my whole thought for the speed up was that we get out of the scheduling hell and just run more frames. But speed up right now has put us further into the scheduler.
Because You're right.
Yeah, so our default tick is 1.
It kind of depends on what we think the problem is, right? Do we think the problem is is prioritization, or is there literally just so much contention? Because we basically by setting ticks per update to 1, we should have halved the gap time.
Half the gap time
between updates on my computer, but we're just running fewer ticks per update.
Right. But I'm running 2 ticks per update every third of a second really consistently, and you're running 1 tick per update every 60th of a second inconsistently. Yeah. So I think we want to. I should be running 1 per second, 1 per 60th, one tick every 60th, and you should be running 4 ticks every 15th until you catch up, and I think you'll catch up because those ticks should go faster. So I think my hypothesis is the problem is JavaScript scheduling.
Right. That is a really cool observation. So what the nice thing is it's just
flip the numbers.
Just sit on the CPU for longer.
Yeah.
Okay.
Yeah. So our default tick should be 1, and then the speed up we could try 4.
Yeah. Or any whole number, really, right?
But I think as the fast client, I should definitely be like attempting to do one to one.
Yeah. All right, I'm gonna cancel that. I think there's enough going on my computer right now that like
Your poor computer.
yeah. Maybe Windows is the way. I've got 12 hyperthreads on that computer.
So here's another thought.
Yeah.
Connect the iPad, run it in the browser on the iPad in QuickTime.
And do QuickTime.
Yeah.
We could totally do that.
Basically finding ways to take this game off of your CPU.
Yes. Oh, that's actually a really good idea.
Yeah.
So we basically have QuickTime in this third right here.
Mm-hmm.
Or whatever. Yeah, that's great.
Yeah, do you have the keyboard case with the mouse for your iPad?
I did not buy that.
Oh, because I've just got like a normal mouse pointer, which is pretty cool.
All right, so this is pretty rough. Still pretty shite over here.
Yep, you're getting slower.
Yeah.
You're getting slower by 4 frames per second. It looks like.
Yeah, my FPS is bad. What we want is that FPS to get up to 60, right? Because my FPS is not 60.
Right. Interesting.
What if we did?
You're just like go to town on this sucker, huh? Yeah.
Okay, so here's the thing that we could do. Is what we could say is that the reason why we are trying to like maintain parity between the number of ticks we run per update and how we schedule the update is that we're trying to maintain frame rate on my side. Render frame rate, right? We're trying to make it seem like we're moving the game at the regular speed.
Correct.
However, maybe the priority should actually be to keep me up with the game rather than to give me a smooth looking experience. Like, do you ever play games that are multiplayer where your game suddenly accelerates?
Absolutely.
Like the characters move more quickly and stuff like that?
Yeah, totally.
So maybe we just need to allow this computer to basically get into that mode.
Which I thought that's what we were doing just now, but it's not quite getting there.
I mean, I bet there's a number that will get us there. We could try 8, like something really exaggerated, right?
And let's set the base back to 1. I don't know if you did that. Sorry. The default's still 2, I think.
Oh, I see what you're saying.
Yeah. Because I want you to be 8 times faster than me instead of just 4. Yeah.
But the problem is that because we're also proportionally adjusting the scheduling amount, the gap time.
Right.
I don't know, but it still feels like we should be able to hit that gap time. Like it feels like the scheduler should basically apply a constant amount of lag to a particular event.
Yeah,
regardless of what my scheduling time is, right?
Yeah, we're trading like fine precision for like more consistent updates on the slower client, and hopefully that's okay.
Well, what's going to happen is the slower client, the input's going to feel really shitty, right? All right, let's try reloading.
Oh, right, because you're actually going to apply. Okay.
Yeah, I mean, yeah, I'm already behind.
That's so bizarre.
It's bizarre.
Oh, all right.
So what if we did separate it, right? What if we did just say, okay, stop. What if we did say ticks per update, this dot update period equals simulation period S. And if we went to speed up mode.
Oh, real quick, did we ever even confirm we went into speed up mode?
That is a really excellent question. I mean, it feels like the behavior has changed a little bit when we've been doing this. So
I know it's just so hard to tell.
Well, how about I do this? I actually think that there's a really nice way of doing this. First of all,
More text. Yeah.
yes, I've actually kind of been wanting to get some kind of telemetry going on here where we output statistics to a server somewhere that can show us like a graph with a moving line and that sort of thing. Would be fun.
Damn, dude.
Update, and then this update frame durations is rename tick durations, right?
Oh shit! You rename both of them. I don't know if you intend.
Fine.
Okay.
This doesn't exist yet, and then I need to readjust. I used to have techniques for dealing with this, because like this is like a very common debug draw thing where you have to like go and update all the.
That's funny.
Update durations doesn't exist yet. But we can just simply. One does not simply. We can simply. Start to crank these out. Then the update, where do we do the tick duration? Oh, we got to store a lot of time. Sorry. So this is actually last tick at. And then this is now last update at. Oh, we are way past time, by the way.
I know.
Having a good time.
It's happening, yeah.
Yeah. And then, why did it not like the update period?
Oh, did it not rename in? That's 9.
No, it did rename. I just didn't. Holy hell!
Sorry, I should have given you. I should have given you a 5-minute warning, but we were really like, there's just so much happening.
No, I'm totally fine. I'm just this class is getting big. Okay. Did that do it? There's no TypeScript errors. I just typed a bunch of stuff just now, and I'm a little bit worried that.
Let's find out.
Now, approaching 14,000 frames behind the server. Good times.
It seems fine.
Yeah, whatever. Or ahead of the server, actually. No, right. Wait, I'm now in the land of pure prediction, right? Yeah. And it's choppy. I'm pretty sure the speed up is happening, because like when I see this, it's like super choppy to me. It's like still like aggregate the same speed as before, but like it's chunky. Right?
Interesting.
Is what we would expect.
Yeah, absolutely.
Yeah.
Huh. It's what we would expect because are we only sampling the input manager once in that period?
No, what's happening is that
we run 8 frames and then we wait a weirder amount of time, then we start sampling again. So you have like a
we're just like when we move objects to the universe, we're only doing it once every 4 or 5 render frames. So you're going to just see it jump.
Yep.
Which is fine. I think when you're in purgatory when you're behind, right? When you get speed up, you're in the penalty box, right?
Oh, cool. Hey, that's totally.
Yeah. What's your update FPS? It's like 60?
60.
Mine is less than 10 right now, which is kind of what we expected.
That is interesting.
We actually, wait, shouldn't it be 60 divided by 8, which is like 7.5?
Should be.
Yeah. Okay. So it's kind of gotten there. It's now less than 7.
Yeah. And notably, though, your tick FPS is at a very pleasant, very close to 60. Is it
interesting.
Above 60?
It is above 60.
Is it 69? Nice.
It is not 69.
Oh, it's a 0. Okay.
So let's go super crazy. Let's go really crazy here. Let's actually take that to to 10.
Okay.
Um,
but it's interesting because it does. I feel like you should have
this
caught
should
up to
solve
me.
the problem.
Now, you're still. I'm 20 frames ahead of the server at all times. Like just a nice even 20. Is there any way for you to catch up to me?
If my FPS, only if my FPS goes above 60.
Right. So I guess
we have to like let the client see like a sped up simulation, right?
And maybe this is what you're getting at, but like, are you thinking that we actually modify update period as well until they get sped up?
That's why I made it a separate variable.
Cool.
Right?
Yeah.
So I think that's only a viable solution if we
can slow down again.
However, I don't know. I think what we're getting into is the realm of like having some kind of modulated thing where it'll reach a steady state where maybe you're running slightly faster and the game will feel weird. But maybe it's okay.
I think if it's sort of like varying into speed up only occasionally, and if our speed up is actually like closer to, if we like have your updates running at like 1.2x or something.
Yeah.
I feel like actually we'll like find a nice balance that won't feel too weird and will account for a bunch of different client behaviors.
Yeah. Okay, so if I did just 10 now, I'm going to reload.
Cool. Oh, reload.
I feel like you were right in that we sort of got to the right direction here. Okay, when my FAOS gets below -1, I should speed up now. You should see my update FPS go down significantly. It's a running average, so it's going to go down over time.
You know, it's interesting. My update FPS also just went to 10.
Oh.
And I'm definitely in the land of chunky inputs.
So you received the speed up message for whatever reason.
I did.
And now you can't slow down, even though you're the leader.
I can never slow down.
Yeah. All right, so this experiment didn't work. However, if I did ticks per update, what's in between doubling the speed? If we did like 3 ticks per update, and then we set the simulation period, we set the simulation period to 30 FPS. This dot period.
This is this dot update. Yeah,
it's like 1,000 times simulation period in seconds
over 30
divided by 2. So I should be running at like 90 ticks per. Like that should take me to 90, right?
Oh yeah, interesting.
And then what we need to do here is actually initialize. Oh, update period is already being set. Fantastic.
All now you just set one that's 1,000 times that. So we're on the wrong scale for something.
Agreed. Gotta stop the server.
It's that bad, huh? Damn.
Well, it's fighting Visual Studio right now. So this is 1,000, right?
Yeah. Yeah, if that's our base, that's cool.
Okay, cool. Boy, it still hasn't. Come on. Now I feel like this is Zoom messing with me.
It must be.
Okay, it's saved. All right. So now what's going to happen is when I speed up, I should be running at 90 ticks per second. And then you're going to get, basically what's going to happen is I'm going to simulate way ahead of you.
Then I'm going to speed up.
Then you're going to speed up, and then
you're going to fall behind again.
I'll fall behind again. That's what we expect here.
Cool.
Look how long it takes to compile.
This is bonkers.
Jobs. Because at this point, it actually printed out that we're creating the bundle. And what that is when let's go to build client, for example. It prints this out immediately. So
yikes.
The difference between like when we said spawning build jobs and then it said creating bundle is like however long it took to arrive right here.
What is the import in common though? Because that could be huge.
Could be huge. It's also doing TS node here.
Mm-hmm.
So, yeah. So yeah, it's compiling all of that stuff.
Still,
right, reload.
This is Ruby speed, not JavaScript speed.
Yeah. All right. I am behind. I should speed up. Oh, that didn't do what I expected.
I am 60 frames ahead of the server and running fast.
I'm still falling behind, but my tick FPS is really high right now.
Yep.
But my tick FPS?
My tick FPS is 90. My update is 30. So I've also sped up, and the game feels faster, which is unfortunate. But
okay, so I think what happened is I started to speed up, and then you sped up because I shot right past you.
Yep, I think so.
Yeah, it doesn't take long, right?
No, but this is interesting. So the game is actually, my game feels like it's running like 30% faster, 50% faster.
50%.
Yeah. And at some point the server should be like, okay, chill out. I feel like this feels tunable. This is cool.
Yep. I think as long as the server's kind of saying, okay, you're too fast. Okay, you're too slow. And we may need a longer buffer time to be able to like smooth that out.
Yep.
But I think this is workable, right?
I agree. Yeah.
But
yeah. Interestingly, this dropped my render FPS to 30, and I don't quite understand why.
Yeah. I think we're going to need to change our guns. I think our guns are not going to have to... like, I wonder if we should do... Well, you kind of want to do a gun that... I was reading that Valorant? Valorant?
I don't know.
Valorant?
Valorant.
Maybe it's like Valor
Ant.
is the Valorant. Having the characteristics of Valor, is that what they're going for?
I think so.
It feels like a made-up word, right? Did they just invent that word?
They definitely invented that word.
Yeah. Well, I was reading their blog post, and the server figures out, like, because you're always like shooting at like a past version of your target, you're never going to hit the target if it was just like based on this like the deterministic simulation.
Yeah.
So the server actually has to basically kind of know what version of the other guy you saw, and will credit you with a hit if you honestly hit that version that version of the...
Oh gosh, that's... yeah.
Server's like projecting multiple futures, right? It's like imagining multiple alternate realities. It's super quantum, right?
Damn.
Yeah. All right. Well, on that note, we're 20 minutes past.
Yep.
Clearly, this is like a really absorbing technical problem because we're just like, oh, the time's flying by. But I think this feels good. Should we merge the master? Is this?
Yeah. Let's. This is. I mean, it's better than master right now. So yeah.
Okay. All right. Sounds good. Well, because master doesn't run on multiple computers right now.
Yeah, this is cooler.
Okay. All right. Well, Monday, Thursday. So I guess we'll see everybody on Thursday then.
See you on Thursday.
In October.
Oh, damn. Yep, it is, isn't it?
Also, Dominic, happy 40th session.
Happy 40th session.
Happy 40th. Yeah.
Ooh, weird.
This is like the second 40th milestone, 40th type milestone that I've had this year. Yeah.
I feel like a youngin' over here.
Yeah, yeah. All right. I will talk to you later.
All right. See ya.